Hello. Welcome. Today is a practice day, so just got some free responses we're looking at. That's what's up. I am still loading in. Hello. So this is a free response question from a little while back. It was a calculator allowed question, although you probably don't need a calculator for most of it. It's pretty reasonable to do without a calculator, but also fine to use one since it was an allowed question. So I tried to pick questions that I thought would be somewhat close to what's going to be on the AP test. So calculator allowed questions that maybe don't require the use of a ton of a calculator, because that's probably how they're going to ask questions, if I had to guess. Sorry if you're talking in chat. I cannot find my video because I'm logged in as myself, and for some reason it's really hard to find your video when you're logged in as yourself, which is a really weird thing. They assume you don't want to watch yourself, which I guess is reasonable. Let's make sure I am streaming. Yes. Live for 242, no drop frames. So I just can't find myself. It's okay. And booyah, found it. Alright. Hello, everyone. Hello, Chelsea, Aspen, Michael, Kelly, Elise, Rose, Matthew, Andrew, Daikun, Tim, Margaret, and Keith. I can find it on my phone and not computer. Yeah, the computer, I don't know what's up with that. Like, I have the issue for probably, I don't know, 50% of the time it takes me 2 or 3 minutes to find it on the computer, which is really weird. It's an odd piece. Is the point 2,7? I can't see. There's a 3,10 point and a 10,10 point. What can't people see? Oh. Folks, if you know it goes through 0, 0 and you know it goes through 310, you can figure out where 2 is. You don't need to see to figure it out. Just FYI. So there is an exact answer to that, not a ballpark sort of answer. Yeah, I'm reasonably certain this could all be done without a calculator with our skills, but Why waste time if you don't have to? Oh, Drew's done already? 4 minutes in? Dang. Speed demon. It turns out the AP test was easier in 2000, so if you think this question's easier, it's because it is. If you had taken the AP test 20 years ago, it would have been easier. Another done sneaking in. Seems good. So yeah, these Wednesday streams are going to keep going for another, I believe, 3 weeks. Because no, just 2 more weeks. Wow. That's kind of crazy. The AP test is so soon. Sorry, 2 weeks. And then I'm going to be switching Wednesday streams over for Algebra 1 after this. So, just another 2 weeks of you guys having the Wednesday slot. Because after this, what we're going to be doing is doing volumes, because we didn't do it on the, because it didn't show up on the AP test, but it's something you need to know for the class you'll place into, assuming you get like a 5 on the AP test, so it's something we're going to cover. I'm a bit late. Can you do a 30-second review of everything you just talked about? I don't know. It's just telling people the AP exam's in a week and a half, or 2 weeks, 2.5 weeks. So we only have 2 more weeks of Wednesday streams. Otherwise, people are doing this question, and a lot of people are done. So it might be time to mob this. That's about 10 dones. 9 dones. Wait, math question first. Okay, so for the for runner A, everything is gravy. So I'm just going to go through and do all the runner A's first. Velocity, it's the point on the graph, which if you do 10 thirds, it means it's going up by 3 1/3 every time it goes over 1, so it goes up to 6 2/3. The acceleration is the slope of that line, which I just said was 3 1/3. So, dope. And the total distance run, that's the hardest part of this. You just have to find the area of these parts. 7 times 10 is 70, and 3 times 10 divided by 2 is 15. So the runner A is running 85. So the graph part is pretty easy. Runner B, we have to use the equation, so things are a little harder, but not really. It's like 48 over 7. You just plug 2 in for the velocity. I do need to put units for all these, so I should have been doing that. Meters per second squared, and meters per second. And the next one will be meters per second squared. If you use your calculator to take the derivative of this and plug it in, you should get 1.469 meters per second squared. You could also do the quotient rule with this, and that would have worked out just fine. So legit. How long is this stream? Well, I believe I have to stop at 3 p.m., so it will not be longer than an hour. I don't know otherwise. I just have like 4 slides worth of questions. If we finish those earlier, dope. If we don't, then we go an hour and stop when we have to. Okay, last part. So again, all I did was take the derivative of this and plug in 2. So you can do that on a calculator just by doing the derivative at a point tool. You can do it in Desmos by doing d over dx of the garbage and then just plugging a 2 in. There's a lot of different methods for doing that sort of question. And then the bottom one, find the total distance traveled. All you had to do was integrate from 0 to 10 of 24t over 2t plus 3. But there's a little caveat. Because distance traveled, we need to be very careful that we're not plugging in a negative. Would we end up plugging in a negative? It looks like we probably wouldn't. But you should still be careful. And anytime you see distance traveled, which distance run is distance traveled, put absolute values in there just in case. It looks like this one wasn't evil, so it would have never given us a negative. You'd get the same answer either way. But it's good to be safe. Did I see what OSPI just put out? What did OSPI just put out? Fill me in. By the way, this answer is 83.336 meters. I scan those emails, but they're usually pretty boring. Every student will get an opportunity to improve their grade with their March 17 status as a baseline. Yeah, word. Okay, so that's a thing, but the district hasn't even decided if we're doing pass-fail, so I don't know what that means in relation to us. So until we get some direction from the district, that is meaningless to me. And you can always redo old homeworks if you haven't done those for grades right now. But until we know more about that, that's just a useless directive. Oh, no student will receive a pass-fail or no credit for any course. They banned pass-fail. Huh. And your grade can't get lower than your current grade. Yeah, seems reasonable. Okay. Seems like a really unnecessary rule, but interesting. That's fascinating. Oh, geez. I can't wait to get the district update on what that means. Because I'm sure they're going to give us more direction. No, our district has to follow it, but they're going to have their own interpretation, so I kind of got to hold my horses. So are people good on this question? There's a lot of other talk there. Oh, yeah, incomplete instead of fail. Oh, A or fail. That's not pass-fail. Oh, man. That's hilarious. A or fail. Or A or incomplete. Oh, that's hilarious. Anyways. I'm dying. Jonah, I'm not going to review those trig identities because they're not really relevant to the AP tests. They don't make you do those trig identities. I want that. Give me an A. Yeah, I have not received anything from the district about that stuff. So, yeah, I definitely haven't received anything from the district on it yet. So we're still waiting for the district to tell me what to do. I can't make stuff up yet. Trying to raise their property values. I don't think Seattle wants to raise their property values. I think that's And yeah, trig identities are not going to be on the AP tests. The only trig identity on the AP tests is this one. Sine squared x plus cosine squared x equals 1. You could use another trig identity, but it will not ever be necessary besides this one. And you need to know these really complicated trig identities, that secant of x is 1 over cosine of x, that like cotangent of x equals cosine of x over sine of x. That's this kind of stuff that's necessary for the AP tests. There's nothing about integrating trig. Yes, basic secant squared x. You'd have to integrate because you can just get tangent x plus c or whatever. But yeah, nothing where you have to like rewrite it a ton. will be on the AP tests because they don't make you do any of the whatever they are, secant squared x minus 1 equals tangent squared x or whatever garbage it is. I don't remember what it is, and I'm too lazy to prove it. It's like divide this by sine squared x, and that's the rule. Or divide by cosine squared x, and you get the other one. But yeah, you don't need these. And isn't it open book? Yeah, so honestly, if it's open book, just print or have the tab open for the Wikipedia trig identities section, and then you're not scared. What about the linear line approximation or inverse trig integration derivative? Oh, inverse trig stuff for sure could be on there. So you do need to know that stuff. Linear line approximation is literally tangent lines. It's not very scary. So don't be afraid of that. Like, linear line approximation just means make a line at the point they give you and estimate the next point. Okay, here's another free response question off the same test that might be even easier than the previous one, assuming you know this skill, which is that reading derivative graphs skill. For inverse trig, just have the packet in front of you, LOL. Yeah, that. What Aspen said. Like, don't be afraid of memorizing anything for this test. Like, really, it's going to be super processy. Like, this question's a pretty good example of a kind of question they'd ask parts of, because you have to, like, understand what this picture's telling you. But if you do, it's pretty fast. So, how do you do left Riemann sum? You just pick the left value. So, while people are working on this, I'll do the Riemann sum thing. I mean, if you have an XY table like this, you just do the first interval's 2 wide and the left value is 1. The second interval is 2 wide and the left value is 3. The third interval is 2 wide and the left value is 9. Done. Riemann sum. Mobbed. Oh, sure, we could do one of those questions. The differential equations questions like that. Will there be an attendance Google form for this stream? No. There will not be an attendance Google form for the stream. I'm allowed to assess you for a total of an hour and a half of work a week. So what I'm assessing you for this week is the Monday and Thursday streams. So this is more just AP preparation sort of stuff. By the way, right Riemann sum would just not have this term and would just have 2 times negative 1 for the last term. So there's not a huge difference between left and right Riemann sums. You just pick the right value or you pick the left value. Wow. Let me know when you're done with this one. And pray that there is a question like this on the AP tests, because man, this is a nice one. Oh, if you forgot to check in for the last stream, just go do it now. If you were there, go do it. I have not checked it yet. I was going to check it probably today, actually, after this, because a few people emailed me about homework grades, so I got to put in some homework grades. And it's probably better to not play Path of Exile for a little bit, or Civ 6, or EU4, or whatever else I'm playing right now. Kind of depends on which friend's online on a given night. About 3 duns in. Fallout 2020, that's not the one. Isn't that just real life? Dome, nice. Oh, okay, okay. Yeah, I haven't driven my car in like 3 weeks. My wife's pretty mad at me because it might not start next time or something. Whatever. All right, let's mob this. So I picked this question partly because it was a pretty fast question. So, um, relative minimum was at -1 because that's where it switches from decreasing to increasing. -5 is our relative maximum because that's where it switches from increasing to decreasing. Cool. A and B are done. Like we're like I point at these, so it actually is more obvious. A and B. Find all the points where the second derivative is less than 0. Since this is a derivative graph, I'm just looking for the parts of the graph where my graph is decreasing. So that's from -7 to -3, and from -2 to, +2 to 5. So -7 to -3, and +2 to 5. Boom. Second derivative less than 0. And last one, at what value does it attain an absolute maximum? Uh, so we start off at some value at -7. It doesn't even actually matter what it is. We go up for a little bit. So this is a possible choice. Since this was our relative maximum, this is a potential choice for the answer for this. Then we go down for a little bit. So it's definitely not at A that we attain our maximum. I'm looking at area under the curve to look at the change in the value of f, which is where I find absolute maximum. Then I go up for a while. And these two ups together are definitely bigger than that down. So at 5 here, I'm definitely at a higher location than my starting location or my B or A, because this is a lot of up here. This up is bigger than this down even. But then we go up even more until we hit 7. So where is the highest point? It's at 7. Isn't concave down 7 to -3? 2 to 3. I assume there wasn't a vertical line there, because I believe it's a function. So it kind of depends on whether or not you call that a vertical line, Chelsea. Oh, it is a vertical line. Psych, it says in the question. Yeah, I agree with you, Chelsea. Let's fix that. Split that up. Don't include the 3. 3 is trash because it's a vertical tangent, and it does tell us that in the question. Vertical tangents are evil. And so let's fix that up. So yeah, I agree with Chelsea on that one. And the last one, yeah, was just x equals 7. The very end point is definitely our highest point because we gained a lot more than we lost on this interval. And that's all there is to this. So note to self, read the question. Was this problem from a past AP test? Yeah, actually. This is from 2000. This 20 years ago was what kids were expected to do. These last two questions, you may have noticed these are easier than a lot of the ones we practice. It's because the AP tests used to be easier. The questions aren't like bad or totally different, but the yeah, this is a past AP test question. All right. Moving forward, I have smorgasbord limits. Just like last stream, I have a handful of limits, although these ones require very, very different techniques than the ones from last stream. So take a peek at these. let's see, I have one question to do at the end here that Chelsea asked for. Were calculators different back then? Yeah. Let's see, 2000. That's earlier than the one even I would have taken. So, it might have been before TI-83s even. So the other calculators were a lot less effective. We're not talking like slide rule or like the super old calculators. I did not take the AP test. I took the IB tests because I went to North Shore, and they're like Skyline with the IB stuff. So I never took the AP tests. I did not do the IB diploma though, because I was a slacker. Probably should have. This is fascinating stuff. Jonah, you're such a hater. I give up. I forgot how to do these. Oh, all of them? That sad panda. I am not getting the first one right. Oh, okay. Yeah, the first one has actually, I believe, in a few different forms, been on the last two AP tests. But they was always on multiple choice, so I don't know if it'll show up on this one, but it's a good kind of question to review. So I'm glad I did it. All right. So let's take a peek at these, since we're getting a lot of people complaining about the first one. This first one's an integral. And this is the integral sign. It's add together infinity rectangles. That's what this integral sign means, is add together infinity rectangles. And that's what this sum means. Take the limit as m approaches infinity of starting at 1 all the way to infinity rectangles and add them all together. This is the addition sign. So that's all that stuff. This 2 is the value we're starting at, because think about this as like a x value in here, and we're starting at an x value of 2 and going just over 1 because it's 1I over n. So it's just an integral from 2 to 3. And if this whole thing is x, then this is just x to the 4th dx. Oh, did I goof? This should have been a 1 over n. So I apologize. If you got confused because there was an I over n there, you should have gotten confused. But oh well. If that was a 1, that would have been much more doable. But yeah, that just makes it this integral. And then you just have to solve this integral, x to the 5th over 5, plug in 2 and 3. You get 3 to the 5th, which is 243 over 5 minus 32 over 5. So 211 over 5? Wow. 42.2. How is it from 2 to 3? Well, this 2 plus is really the key part. There's actually two different ways to think about this. You can call this the integral of 2 plus x to the 4th dx and integrate from 0 to 1, which yields exactly the same answer. Or you can call it the integral from 2 to 3, since because of this 2 value, we start our values inside that parentheses at 2, and then we start adding crap to it. So those are the key pieces of this. We did not do a sign-in today. Monday and Thursday are sign-in streams because I'm only allowed to assess you for an hour and a half of stuff a week. All right. The second one. This just means take the derivative of 2 minus x to the 10th. Because this is f of x plus delta x minus f of x all over delta x, that sort of garbage. And so if we do that, we get 10 times 2 minus x to the 9th times negative 1 for chain rule. And that's the answer I was looking for. Oh, how did I know it was to 3? Well, if this is a 1 up here, then I know the integral's 1 wide. It should have been a 1. I put an I there instead of a 1, which was a bit of a derp when I prepared this. And so this is how you know the width. And so I know it's either from 0 to 1, which is 1 wide, or from 2 to 3, which is 1 wide. And so the width is always comes from this dude out here. If it's 2 over n, we'd have a width of 2. If it's 5 over n, we'd have a width of 5. And so, yeah, what you can read Jonah's comment too. That's helpful as well. It's what you're dividing by n, so it's the number of rectangles or how wide each rectangle is. This last thing is always dx, which is how we can find the width from it. All right, the third one. Cosine squared x goes between 0 and 1. And then if you add that to 1, you get like a small bottom. It's like between 1 and 2 on the bottom. On the top, you get infinity. So infinity divided by 1 or 2 is infinity. So, yep, it was infinity for the last one, for the third one. So, because I derped on that first one, let's give people another try. I'm going to wipe all this out and just write a new one of these limit questions. So let's do this. And let's see if people can get this integral. Yeah, you can just write the integral for this. Don't solve it. It's a waste of time. Write integral. I'm going to give people a minute or two, and then I'm going to go over it. We'll see how people did. Alright, them duns are piling in. Alright, what I got for this is the integral from 0 to 2 of sine of 3 plus 2x dx. Anybody have any beef with this answer? Or are people like, yeah, that's what I got. What? I'm assuming Liam's response. Isn't there another way to write it? I think so. The other way is harder. Things fall apart when these don't match very well, and it makes it a little harder. Jonah, this is the limit definition of the integral or infinite Riemann sums. That's what this is. I usually call it limit definition of the integral, because that's what it is. This is the limit definition of an integral. Infinity rectangles, blah, blah, blah. Isn't there a way to write it with different bounds? I think so. So this is where things get a little shady. So you can rewrite this as sine of 2 times 1.5 plus 2i over n, and then you could do this as the integral from 1.5 to 3.5 of sine of 2x dx. I think this is legit. I think you're allowed to do this. I don't think any of the other ways work. I think a lot of people may have been baited into doing like the integral from 3 to 5 of sine of something, but this isn't consistent and doesn't keep the inside consistent. And so you can't walk this direction. You actually have to factor out a 2, and usually those are harder than what shows up on the AP test. The kind where you actually have to nuance do the inside here. And I've only ever seen these show up as multiple choice. This year might be different because the whole test is free response. But, yeah. Oh, how did I get 2x? I called this x, Liam. So the inside of the sine, I factored out a 2 out of the inside. And then all I was left with was dx times I plus 1.5, which I can call x. So my x's start at 1.5 and go on, and I have a 2 inside that is multiplied by that x piece. And so you have to be a little careful when you do these. They can be a little tricky. What? So so what I did was I took sine of 3 plus 4i over n, and I factored a 2 out of the inside. Now, 2 over n perfectly matches my dx piece from my original problem, and that's how I can rewrite this in terms of what x is. My starting x value plus my change in x, because this has to match this, to match my width of my rectangles in order to get the piece. Oh, how did I get 3 plus 2x originally? The way I got 3 plus 2x is this is 3 plus 2 times 2i over n, which would have been just normal x. So the fact that 4 is double 2 is how I got the 2x, and the 3 just comes along for the ride. So x in these problems is always dx times I, and then plus whatever offset, if you want to do it that way, like this bottom one. But you may notice that if you integrate both of these, you actually get the same thing either way, and that's a proof that it's consistent. And by the same thing, I mean when you plug in 2 and 3.5, you get 7 in both the parentheses, and when you plug in 0 and 1.5, you get 3 in both of the parentheses, making both of these legit. Why is it not 4x? Because our width is 2, and so our x term here is only double the 2. If this was a 1 on the outside, it would have been a 4x inside the parentheses, so sine of 3 plus 4x. But because it's a 2 on the outside, we only have double our width of our rectangles. All right. Based on the feedback, let's try another one. Oops, we're not doing an integral yet. Let's do a limit as n approaches infinity of... Gosh darn it, that was a really bad sum sign. Sum of I equals 1 to n of, let's try one more, 7 plus 6i over n to the 11th times 2i over n, or 2 over n, whoops, not I. There we go. This question should be doable. Let's try. And yeah, Daikun, 4 divided by 2 is why it's not 4x. It's 2x. So this question should feel pretty similar to the last question we did, for obvious reasons. Done, yeet. All right. Let's see how people did. I called this the integral from 0 to 2 of 7 plus 3x to the 11th dx. I do not play Valorant. Are people feeling better about this? Do people see this? Oh, come on, Liam. Use appropriate language. I could report you. That's funny. Uh, sweet. Why aren't the bounds from 7 to 9? The bounds aren't from 7 to 9 because this and this don't match. When this and this match, when the 2 and the number in front of the I inside match, we can just substitute x for x and be chillin'. Like if this was 2i over n in here, so if I made that a 2i, it would be from 7 to 9. But because it's not 2i over n, we're actually modulating the width of our x values, which changes our initial x value. And the way it does that is I have to take a 3 out in that parenthesis and get 7/3 plus 2i over n for it to match my x on the outside, or my dx on the outside. Now I could use this 7/3 as the bottom bound and go up 2 from there. And that would be legit. So I could do 7/3 and plus 2, 13/3. And I could use these as bounds, but this is a much more complicated way to go. This is the easy way. So I would stay on this sort of path. All right. Sorry, that was a large digression, but I kind of wanted to review that limit definition thing. Okay. Now I got these two questions. And while you're doing these, I'm going to see if I can't find a... Oh, I definitely can find a question that answers Chelsea's question, because I didn't quiz on this section enough in class, so I have plenty of leftovers on my flash drive. Oh, dang it, it went off page? No, I just scrolled. We're chilling. These are both visible. Sweet. You may recognize these questions as some of your favorite from throughout the year. There is no height. Well, it tells you something about the height. So, if you reread the first sentence, particularly the part after the comma, you should be chilling. What is the volume of a cone? It's third pi r squared h. Like this. love that Seattle's doing A or fail. That's fantastic. It's so funny. So these are pretty shades of first semester, these questions. See how your implicit differentiation is held up, or your word problem creation, problem solving skills. Liam, if that's the aspen, she's right. Height is equal to the diameter. That's what it says in the question. Oh, anybody played the Mountain Blade 2? That's a game I've thought about buying. I played the first one a crud ton in college. I was wondering if anybody... I think my friend's little brother was playing it. I haven't asked him about it, though. Probably should. He'll probably be online tonight. Just realized the assessing 45 minutes a week, or an hour and a half rather, of work a week is going to be really awkward after, like the week after the AP test. Because normally we just watch movies in class, but we're not in class. Will there be GPA this semester? It seems like that's a yes, according to people. Seems like the OSPI statement says that there will be GPA. And it seems like if we follow in Seattle's footsteps, it's going to help your GPA. I don't know if you guys can't tell, but I don't care about grades at all, really. I only care about them as the carrot, and I think it's very funny. All of this winging it that people are doing. And so, stream movies for us. Why? You all have Netflix and stuff. To maximize the yield, you plant as many trees as you can afford. I don't think so. I think there is a maximum number here. Because if you, Daikun, if you plant 80 trees, each tree produces 0 apples. You have killed the trees. So that sucks. And by that I mean 130 total trees. Okay. Oh, we should finish like right on an hour. Because we have one question after this. Chelsea's question from the beginning. Which I might just have to do to finish within the hour. Yeah, it does decrease. Yeah. I'm probably going to start this in like a minute or so, the going over part. So see where you can get. And yeah, I just looked up the OSPI stuff. It's really funny. Oh man. Can't wait for the district's take on this. Why would the district not want pass-fail? Or, sorry, not the state. That's very confusing. Like, do they understand online assessment and its weaknesses? Oh, man. Fascinating. uh... Alright. So what I did on the first one was started off with an R over H ratio. Because R is 4, and H is 5, or 8 rather, meters. Because the height is equal to the diameter, so the radius is half that. So my R over H is 4 over 8, so R equals 1/2 H. Something I know. So I can plug that back in over here. And I can get V equals 1/3 pi times 1/2 H squared H. Like so. Wait, is the stay-at-home order till we find a vaccine? Not necessarily, Liam. We could potentially go back to school for some of next year, and then anytime there's a flare-up, go back out of school. But reasonable chance to plan for some online school next year. Anyways, 1/3 times 1/4 is 1/12, so I can rewrite this as 1/12 pi h cubed. And now I'm ready to take a derivative and get dv dt equals 1/12 times pi times 3h squared dh dt. And dv dt is 2 cubic centimeters per minute, so 2. 3 divided by 12 is 1/4. H is 8. And this is all I have to solve for dh dt. So 64 divided by 4 is 16, so it's 2 over 16 pi, or 1 over 8 pi. And it's a rate of change of a height, so it's in meters per second. Booyah. Feel like this is going to change how teachers are going to teach from now on. Honestly, yes. A lot more of your teachers are going to be using stuff like Teams, especially in the humanities or science departments and that sort of thing. Yeah. More online tools are going to be accepted and used and that sort of thing. Because I was like the weird one who was streaming for a while, and now everyone's doing it. So, hey. Okay, next one. There are 50 apple trees in an orchard. So 50 is part of my equation. Now, I know from doing a million of these that we're going to have the number of trees times the apples per tree, and that equals the total number of apples. Like A over T times T is A, and the yield is the number of apples. So every time I add a tree, I decrease my number of apples, which starts at 800, by 10. And so this is our equation. Honestly, Isaiah, all the teachers are saying that too. But when you learn how to use things, eventually you get used to it and you like them more. So the first few months of any online tool like that kind of sucks. And then when you get good at it, you like it. It's just kind of the way things go. 800 times 50 is 40,000. Plus 800x minus 500x is just plus 300x. I'm just foiling. Minus 10x squared equals A. You take the derivative and you just get 300 minus 20x equals, and you set it equal to 0 because you're trying to find max and min. It's an upside down parabola, so we know, because it's a negative 10x squared. So we know we're getting a maximum already from that. And the critical point happens when this is 0, so when 300 equals 20x, which is at 15. So there should be 65 trees to maximize the number of apples. And that was that. So if you got both of these right, booyah, related rates and optimization, and of probably an approximate difficulty to the kind of stuff on the AP tests. And if you didn't, hey, we got a little more practice. That's pretty good. Do you think the test will have optimization? Yeah. Yep. A ton of the free responses we've done so far have had optimization. Anytime it asks for the like fastest speed or highest points or any of that, it's the process of optimization. It's like absolute extrema in word problems. So that's all optimization is absolute extrema in word problems or relative extrema in word problems. So there's nothing special about optimization. How am I feeling about Journeys In? I'm feeling nothing. I don't know what you're talking about. Haha. The last question was Chelsea's question. And yeah, that is it, Daikun. That was that question. Which I pulled up a question for, so I don't have to wing it. So find M and B. Did I write this off the page? Gotta wait for my stream to catch up. Yes, I did. Okay, find M and B. Y equals mx plus b is the solution to a differential equation, dy over dx equals x plus 3y minus 6. And yes, optimization is just relative or absolute extrema. So yeah, just absolute, basically. Did you watch The Last Dance? No. What did I watch? I watched Babylon Berlin, Poops Creek, which, because I can't swear, but the name has a swear word in it, but kind of not because it's spelled differently. And those are both on Netflix. They were both pretty good. Anyways, so you're given a differential equation and you're given a solution. You know the solution is a line, so you know there's a line that goes through this differential equation at some point. Can your grades improve? I guess we're going to figure out stuff. All right. The way you do these, if you know this is the differential equation and this is the solution, is you plug in the stuff you know. So you know dy dx is m. You know x is x. You know y is mx plus b, so you substitute in mx plus b for y. Like so. Then you just distribute, so you get x plus 3mx plus 3b minus 6 equals m. Then you factor out an x, and you get x times 1 plus 3m plus 3b minus 6 equals m. And then what you know is the slope can't have an x in it if it's a line. So you just set this stuff equal to 0, because if this is equal to 0, then the x is multiplied by 0 and there's no x term. So m is just negative 1/3 in this case. That's the value of m that would make the x term insignificant. And then all we do for the end part is we plug in 0, or plug in m equals negative 1/3, which means I should have written negative 1/3 here. The whole first term is 0, and we just solve for b. So we add 6 to both sides, we get 5 2/3 equals 3b. And then, what is that, 17 over 9 is b, and booyah, m and b acquired. Jordan would be DeMar DeRozan in today's league. No, 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 he wouldn't. Holy crap, Josh. Oh, man. Oh gosh. Oh, that's so wrong. Jordan's handle makes DeMar DeRozan look like he's standing still. Jordan's first step makes DeMar DeRozan look like he's standing still. Jordan's defense makes DeMar DeRozan look like he's standing still. Shooting-wise, fairly similar. Similar type of player, although a little more like Kobe than like DeMar DeRozan, I would say. Like, kind of not great range, but pretty good moves and pretty good on long twos. But come on. You're just baiting with the Jordan would be DeMar DeRozan comment. Yikes. Is there going to be a way to retake quizzes? There are not any ways to retake quizzes right now. I'm still waiting for more direction from the district, folks. So, hold your horses on that one. Anyways, it's 3 o'clock. I'm not supposed to stream anymore. So, I'm going to ditch out. I got to stop ranting about Josh's inane comment. Alright, bye-bye.